Miss Baskin,
Yeah, it is.
can I be totally honest with you right now?
I mean, you.
Just asking. I was struggling on that homework.
Number nine is not gonna get done. I can't do
I mean, I'm gonna get it done. I'll send it through, but it's not done yet.
And number 9, I just don't know how to do.
Miss Baskin, I would say nobody has number 9, and
Yeah.
no one's going to get it. So
I have it. I can help people.
Yeah.
Yes, Johanna. I've been looking for your email, but I realized.
Okay. Well, you all seem like sane humans who can handle having my phone number. So if you want to text me to ask for help, 206-601-5955.
Got it right here. I'm gonna text you right now saying it's a Shiro.
206 what?
206-601-5955.
51 or 59?
The other thing I'll say is
59.
5 what?
You got my text, Johanna?
Oh dear, my
my
phone.
1 5.
yeah, your phone's gonna explode, dear.
Okay.
My number.
What?
Give him my phone.
Oh no, I'm so sorry. Do not text that number. That is my mom's number. I'm so sorry.
Yikes. I don't know
My
how to
mom's
feel
so
right
sorry.
I don't know how to feel right now.
That's hilarious.
I don't really know how to feel.
Mannequin.
Yes, Kennedy, you're in a mood.
Okay.
So hold on. So what I'll say is, I am gonna go over a little bit. Jada had actually requested that I go over question number 9, so I will go over how to solve it. And the homework is just due before you go to bed today, and there is another set of office hours from 4 to 5. So we have multiple opportunities to try and get this homework taken care of. So just keep that in mind. And we'll wait another couple of minutes because we're still missing about 10 or so people.
If by before you go to bed, do you mean 11:59?
No, I mean before you go to bed.
Okay, so like, let's say if I were hypothetically to go to bed at 3 a.m., I'm not going to bed at 3 a.m. Would you accept it at 3 a.m.?
I mean, I'm not going to grade it tonight. I'm going to grade it tomorrow. So basically, as long as it's in my inbox before I wake up tomorrow, which I'm assuming should be, before you go to bed, that will be good.
Okay. Great.
Miss Baskin.
Yes, dear.
Okay, I've been asking a question for a long time, but it's because I was muted. You couldn't hear me. Okay, I just have a quick question. For step 3, when you're doing a liquid, is it up to 100 and starting at 0 degrees?
Oh, for number 9, yeah. So it's from 0 to 100 is what you're heating it to. Yep.
Okay.
Yep.
So I did it right. Okay, thank you.
Cool.
Ms. Baskin, I'm gonna go off and then join back so I can get my camera, okay?
Okay.
Okay.
Okay, so really fast, I'll tell you who I don't see in case you can text one of your friends. I don't see Ashton or Ioannabelle, Shamir, Manny, Davi, Eliora, Jameer, Jayla, and Fabi. That's who I don't see. So if any of y'all want to send out a bat signal to any of them.
It says Davi's in here.
Oh, did I miss that? Oh yeah, Davi's in here. Okay.
I'm here.
Yeah, there you are. Hey, nice plant.
Guys, Johanna put her number in the chat, so if anyone needs her number, click on the chat button. Yeah.
Wait,
Yeah,
what?
Also,
What, Kayla? Oh, there's Ashton.
I put the right number in the
Johanna
chat.
put her number in the chat.
It's the right one this time.
Okay.
Yeah.
There we go. Okay. All right. So today, I'm actually not going over a whole lot of stuff. So I was going to go over one problem in section 4.6. And that problem is like your very last calculation step in the virtual lab. It's not a problem that is you'll see on the homework. It is a lab related question. So we're going to jump into that first. So you will need the physical, section 4.6 so that we can get that done. And then I'm going to go over some stuff about the homework, going to remind people how to get it turned in, how to do all the stuff around that. I'll go over, yes.
Joanna both says she's coming.
Okay. I'll go over how to turn it in, how to set up question 9, and then remind you guys that office hours will be later today if you have any questions. And then we're going to spend some time going over and through the virtual lab. So I'll show you how to access all that stuff. I'll pull it up, the lab itself, so you can start playing around with some of the controls. And I'll go over the next sets of due dates. And
wait,
is that Tracy? Is that your mom?
Thank you. You can. I can.
Miss Askin, thank you for this.
Hi. Okay. Okay, so let's see here. Okay, so in section 4.6, I'm gonna do the problem on page 224. So I'm gonna switch over to my iPad for that. All right. So again, this is problem number 2 on page 224. And in theory, what?
Are you recording this one too?
Of course.
Oh, okay.
Yeah. Okay, so if we were actually at the school, you would literally be doing this thing, like this thing that is described in this problem. You would take a coffee cup with 50 grams of water, and one of the groups would actually be adding ammonium nitrate to it and measuring the temperature. Like this is literally what we would be doing. So the virtual lab is going to have us simulate this with an actual nicer calorimeter instead of the coffee cup. But this is the calculation that is surrounded when you have to do this. So I want to point out a couple of things that are different from the Q equals MCAT problems that we did on Tuesday. So first off, you should notice that there is a mass here, and that's of water. But then there is also a mass here, and that's of ammonium nitrate. Those are 2 different compounds. And then I've got a temperature here, and that was of the water, so that's my initial. And then it mentions this other temperature here, and that's what it dropped down to, so that would be the temperature final. So those are just the numbers. And I know that most of us, when we start looking at a problem, that our eyes are drawn to the numbers without actually reading the words first. So I just want to make sure that that's what we're seeing with the numbers. Now, if you look at all the words around it, what it is literally talking about is if you took this coffee cup and that it had this water, and that water was at 20.73. And then I'm gonna take this powdered bit of stuff and I'm gonna dump it into the water. And then I'm gonna end up with a coffee cup that has now a solution, and that solution is at 17.41 degrees. So it's not water in a separate compound anymore. It's a solution. And that solution's temperature is that. So what it's asking for is, it says this guy. And all that means is it's asking for a delta H of solution. And if you did actually read the section, you'll find that all that means is it is Q, which we know how to get Q, divided by moles. And that's it. So out of all of this information up in the problem, we know how to get Q, and we have the information we need to get moles. So to start off with, let's look at Q, M times C times delta T. Now it gives us a little bit of information here. It says assume that the heat capacity is the same as water. So that means, what am I going to assume C is? You remember that number?
4.184.
4.184.
There we go. 4.184. So I know that. My temperature, I've got two temperature values. Which one is going to go first?
2.13, my bad. Wait, is that what it says?
20.73.
You get my
17.41.
It is 17.41 because it's final minus the initial. Now, you should recognize that that's going to give you a negative number because my temperature went down. All right, so 17.41, 20.73. All right, so I've got that.
Oh.
Now, for my mass, what am I going to use as my mass, do you think?
Do you subtract them because it's 2? Or are you just trying to find the water? You're trying to find the water, so you just use the grams, right?
I'm trying to find the solution, which is actually made of 2 things.
So would you add both?
You don't use subtract them?
I am adding them.
Yeah.
Adding them.
50.00 grams plus 2.
You get 52.13.
Yep. Okay. So all you have to do is multiply those things together. All right, and how many sig figs should this answer have?
4. 4 sig figs.
3.
You're going to be real annoyed. It's not.
I think it's 4. That's what I said. That's what I
Yeah.
said.
And here's why. Because this is addition, so the addition rules say it should fall to here. So even though 2.13 is 3 sig figs, because what we're doing is adding, it still leaves with 4 right there. Stupid addition rules. Okay, so if we do all of that, 4 sig figs, I get negative 724.1. Is that what you're getting in your calculators? I hope.
The calculator wasn't working.
Huh.
Can I use my phone? It doesn't flip. It was supposed to flip and it didn't flip.
Sure, can you go on mute, please?
Shut up, Jameer. Shut up.
Oh my god.
Okay.
Negative 724.1.
0.1. Yep.
Okay.
Okay. So here's where you're going to be annoyed with me. This value is actually the water, because that's what I can measure, right? You have to remember that this is the surroundings, because all I can ever measure is the surroundings. So the solution is simply changing the sign.
Question.
Yes.
If we're just measuring the surroundings, then why did we add the 2.13 for the ammonium nitrate?
Yeah, right? Because technically it does slightly change the water. It's the only way to get the reaction going. This is an annoying thing when you're dealing with calorimetry. All you ever have to remember is what they are actually asking you for is the opposite sign of what you're going to calculate. So you should know that if the temperature dropped, right, which means it's endo or exothermic.
It's an exo.
Endo.
This is endothermic.
I wouldn't.
Okay, because my temperature decreased, so it's endothermic.
Oh, the heat goes in.
Yeah, because heat went in, which means if it's endothermic, should the sign be positive or negative?
Negative.
Positive.
It should be positive, because remember, the plus sign is indicating going in. The plus sign says it's going in. It's endothermic. But
question.
Yes.
Is that why the Q of SDN is positive?
Yes. That is why we changed. That's why exactly why we had to change the sign, because our original calculation gave us negative, and negative would say it's endothermic or exothermic, right? Out, but we know it's endothermic. So the surroundings, yes, the surroundings did. So it's yeah.
So the -7. So the negative number is what's happening to the surrounding.
Yes. Yes.
One more question.
Yes.
Is the mole value that we're using moles of ammonium nitrate?
Yes, that was going to be the last part.
Okay.
Okay, so we have our Q. We have this part. Now we need moles. And if it's talking about solution, then the thing that makes it a solution is not the water. The thing that makes it a solution is the ammonium nitrate. So then we need the moles of ammonium nitrate. I've got grams, so I just need to convert this grams into the moles. So we need the molar mass of ammonium nitrate, which, let's see, I'll do that down here, NH4, NO3. So I've got 2 times 14.01, 28.02, 4 hydrogens, that's 4.04, 3 oxygens, 48. Is that right? 80? Okay, 80.06, sweet. All right, so that's 80.06 grams per mole. So if I have grams and I need mole, am I multiplying or dividing those numbers?
Divide.
Dividing.
Yup. So 2.13 grams, divide. Now this should have how many sig figs?
3.
You should have 3 sig figs.
This is 3, right. Okay, so it's gonna be a small number because I didn't add very much. 266. And again, that first zero is not a significant zero because it's just a placeholder. So that's my moles. So now I have my Q and my moles, and I'm literally just going to divide those two numbers. So 724.1 joules divided by 0.0266 moles. And how many sig figs should my final answer here have?
3.
Again, 3, because it's limited by the moles. And you're going to get a big number. right? 221.80, blah, like I'm gonna get a big number.
27,218.
Yep.
So 27,200.
So I can write that as 27,200 or
Scientific notation.
27.2, because I'm going to put it into kilojoules because this answer is joules. Now, as I said on previous problems, I'll take, you know, either one, kilojoules or joules, but most of the time, if you end up with a really big number like this, put it into kilojoules instead of dealing with scientific notation. Just move your decimal over 3 places, and then that'll switch it over to that. Okay, so I'm going to leave that up for a second to make sure that everybody gets all of that. We're not going to do the problems for number 1 and number 3 because it's just number 2 that's directly applicable to the lab that you're doing. And again, just like last time, like, yes, this is being recorded and I'll pop this video up so you can watch me go through it again before you do the lab problem. But we'll wait another minute or two. If you want to get your homework in front of you, because we'll talk about that and we'll talk about number 9.
Baskin.
Yes.
Enthalpy. No, that's kilojoules over a mole.
Yes.
Okay,
Yeah,
cool.
the word molar there tells you that it's over moles.
Okay.
Yeah. Okay. So.
Wait, hold on, Miss Baskin.
Yeah, sorry.
Okay, could you just, I'll just take a picture of it. Okay, thank you.
Uh-huh. Okay. So you guys specifically had a question about number 9. So, okay. So number 9 is 5 separate problems that you're going to add together. That's how this works. And basically there is a problem to do for each of the bullet points. That's why I kind of put it out to you that way. So it wants to know how much heat energy, so that is Q, how much heat energy is required to convert 54.0 grams, so that's your mass, of ice at negative 15 degrees to steam at 105 degrees. So the thing to remember is that you are starting as a solid. You are increasing your temperature of that solid from negative 15 to 0. Once you hit 0, what happens to ice?
It melts.
It melts and it becomes liquid at 0. It's still at 0. But then you keep adding heat and you get up to 100 degrees. And what happens at 100 degrees?
It turns into steam.
It turns into steam, still at 100 degrees. And then you're going to take that steam up to 105. So the thing that you need are these temperatures to be able to do each of these things. So when it says I've given you the specific heat capacity of ice, that means you are using the negative, your temperature initial here is the negative 15.0. Your temperature final is 0. Because after 0, you're no longer ice. So you've got the mass doesn't change in all of this. So that's your M. There's your 2 T's, and then there's your specific heat. Calculate a Q, get a number. Then for this next portion, this H fuzz, 6.02 kilojoules per mole. So you're going to have to take that 54.0 and convert to moles. Yeah. I have no idea what just happened. And you're going to convert to moles using the molar mass of water, because ice is just water. So 18.02 grams per mole, and you'll get a mole value there, right? So this problem is just like number 1 and 2 and number 1 and 2 on the front. Now, the difference is that this answer here is going to give you kilojoules. This first one is going to give you joules. This is going to become relevant later. So for the next one, specific heat capacity of water, my temperature initial is 0. My temperature final is 100, because that's the temperature range where you have liquid. So again, you've got an M, you've got a C, and use these two to find your delta T, and you're going to get an answer in joules. And then you're going to deal with this section here, just like 1 and 2 on the front, where you have to convert that same mole amount that you used in this step, you'll use in this step, because you still have 54.0 grams. So you'll have the same mole amount, you just multiply it by a different number, and you'll get a kilojoule answer. And then the last one, same M, that's your C. Your temperature initial now is 100, but your temperature final is now 105.0. And you'll get an answer in joules. So you're going to have an answer in joules, kilojoules, joules, kilojoules, and joules. My recommendation is to convert all of the joules into kilojoules. They will become very small numbers. And then you're going to add all 3 of these numbers together to get one number with an answer in kilojoules. So that's how you do it. So the specific heat capacity, so problems 1, 3, and 5 are just Q equals MCAT problems. Problems 2 and 4 are using HFuzz and HFAP. So you've done all of these individual type of problems on the front. The only thing you're having to realize is that you're actually doing 5 problems. It's getting the temperature ranges that are actually the hardest for people to understand where you're doing that. And then you add the answers together. So, yes.
As you go, so like each individual question, you do the sig figs for that.
Yep.
So like for the first one, like you do whatever, like 3 sig figs, and then like all of that stuff. Okay.
Yeah.
And then add it together. And when you add it, you're doing it to the smallest, the
least decimals.
The least decimals. Okay.
Yep. Yeah.
Miss Baskin, I'm so confused. So with the specific heat capacity, so for the first one, we have our TI and TF, but you said to calculate our Q. How do we calculate Q? So do we use, I don't understand. Like, I'm confused. I don't understand.
You're using that.
Yes, but we were only given, so is the 2.05 joules grams, is that RC or is?
Yeah, that's the C, that's
mass,
the specific heat for ice. The mass is the same for all of these, 54.0.
Okay, so the other numbers, those would be RC, the specific heat.
Yeah, so the specific heat, I had to give those to you because we're used to just using 4.184, but it's different.
Okay, I understand now. That's what I was confused about.
Okay. Okay.
Thank you.
Yeah.
After step 3, I kind of like zoned out. So what? What is happening with step 4?
Step 4?
Yes, I got back with step 5. Okay. But like step 4, I don't know what that is.
So this step is when we're boiling off the water. All right. So you're going to use whatever you calculated for moles in step 2. Mm-hmm. It's the same moles because we're still talking about the same mass.
Okay.
So it's essentially, it's about 3 moles, and then it's just multiplying, right? So Q there is going to be equal to the moles times the HVAP.
Okay.
So it's just multiplying your moles by that 40.7. That's it.
Okay, I have a question as well.
Yes, Jada.
When you said for number 4, or yeah, for the first step, when you say use the mode value, do you mean the one from the original problem or the one from the second step?
Oh yeah.
So for steps 1, 3, and 5, you're going to use 54.0 grams because those all have mass in them. But for steps 2 and 4, that moles is 54.0 grams over.
That's coming from the problem.
Yeah.
Okay.
And that is essentially 3.00 moles.
Okay.
And that's the moles you would use for these two. So you're just going to multiply those two numbers by 3. That's it.
Okay. Thank you.
Uh-huh.
I got it.
Miss Baskin?
Yes,
I have one question. So does that mean, because it's the 54.0, does that mean for all of the individual steps, we would round it to 3 sig figs? All right.
Yes. Yeah. Correct. Okay, so if anybody else wants to take a picture of that, take a picture of that. Of course, it'll also be in the video that I'll post later. And then I'm gonna give it just another second, and then I'll switch it back over from my iPad to my computer screen. Give people one last second to.
Ms. Baskin?
Yes,
What
Jack?
time?
I'm confused on the steps that got us to that last part on the bottom. The 4.0 times 1 over 18.02 equals 3.00.
Uh-huh.
How did you do that?
That's just converting grams to moles, because for steps 2 and 4 with the HFuzz and the HVAP, I have to use moles.
Okay.
That's it.
What time are you gonna post the video?
It depends on the internet connection. It should be posted across the lunch hour.
Okay.
So I'll put it both on the original Google Doc, and I'll send it out and remind.
Okay. Thank you.
Okay. Okay. So let's share back here. Okay. All right. So to turn in the homework, this is where I was saying we've got 2 things that I want you to do. I want to make it easier to grade, since these are all number answers. I want you to actually type in your answers into this form. And I've got that right here. It looks like this. That link to that, while it is in this slide deck, it's also on this guy. All right, so I've sent this out multiple times, but if you scroll down here, if you click on this link right here where it says Google Form, this is what's going to open up. And just type in exactly what it says, email address, last name, blah, 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 tell me what period. And then you'll see, like, I'm literally just asking for your answer. But please remember that that answer means to the correct sig figs and with units. Put a space between the number and the units when you enter that in. And then this is going to make it much faster for me to grade. So these are all the calculation problems. So number 6, it was a 2-step problem. You had to like get a number and then tell me what the substance was. So here's your number, here's your substance. Yes.
For number 6, the number was like off a decimal.
Yeah, that's fine.
Okay.
And then for question 8, where you had to do all the labeling, I've just broken it up by segment, right? So everybody should know line segment. So you're just telling me which segment is what. 8C, I am warning you that you should mark multiple ones here. Still only singles there. And then 9 is a single answer. So when you're done with your homework, enter in your answers here. And then I also want that PDF file. If you're having problems getting it to save as a PDF, if you can really only get images, that's fine. I can play around with it and try and convert it, but it is much easier for me to deal with the PDFs. And again, the goal there is if you make any mistakes, I can annotate and add comments to that and then get that back to you. The way you will get it back is in the comment box for the assignment in Aspen will be a link to the assignment that you submit to me. So that's kind of how that will work. So you can see the corrections that I make on your work. And yes, I've said that this is due before you go to bed. Like, that's it. I'm just saying before you go to bed. So really fast, before we move on and talk about the lab, I want to roll the homework die. I brought it home. So we can still see what it is we get. And let's see here. I'm going to throw it at the periodic table, and then everybody's going to see me. Everybody's going to see it. All right. The die says check 3. You can kind of see. Check 3. So this has 9 things on it. So let me take my other die and see what we got here. That was an 11. We don't have an 11. We don't have a 12. Come on. Number 3. So I'm checking number 3. I should write this down. I normally write it on the board. I don't have the board. Okay. Post-it note. So number 3. That's an 11 again. 7. And 8. So 3, 7, and 8 are going to be for your actual grade, but I will, as always, correct and comment on everything. So there we go. We got that. Aren't we glad I remembered to bring that home? Okay. All right. So in the last couple of things here, oops, is the lab. The lab. Okay. So the lab is another thing where you have the links. So again, in this original document, here are the links to the lab and the simulation. So if you click on this simulation site, it pulls up this. And I do not care about the overview or the learning outcomes. We only care about the experiment. And you're going to run the experiment. And the directions all tell you how to do this. But you can tell this is a fancier setup than our little coffee cups. But it is, the calorimeter is actually this thing on the right. And the thing on the left is what you add to it. So you are doing 2 different things. So basically the paper lab, we're chunking because we can't do that exact thing. So I had to modify it a lot. And the way to modify it is basically there's now a form that tells you what to do. The link again is on this plan, right? The form is over there and it pops this up. So the link to the simulation is also right here at the top. And then same thing, you're gonna enter name, blah, blah. So like I'll go ahead and do a dummy like this. So what it looks like is this is the cut and paste material from the paper lab. So I've just re-put in that background. The pre-lab questions are the exact same pre-lab questions from the paper lab. But again, it doesn't matter if you forgot to bring the paper lab home because they're here. So it's the same sort of thing. And I've given you hints on like what to do. It's hard to do the formatting. So like do recognize that that is a degree sign, right? Degrees temperature. You have to identify the metals. So again, I've just put that chart in for you, this sort of thing. And then once you start getting to these numbered steps, these are telling you what to actually do on the simulation. So it says from the opening screen of the simulation, select experiment, run experiment. So that's what I did. And I pulled this screen up. It says for the beaker setup on the left, select the solids tab, right? So solids tab. And it says select any of the first 5 solids. So you just have to tell me which one you want to do, right? So first 5 meaning tin, silver, copper, iron, blah, blah, blah. That's what they are. So just pick one, but then you got to tell me what you picked. And then it says now for the one on the right. So you do that. Oh, I forgot the rest of those steps. Begin with 5 grams and a temperature of 90. So everybody is going to start off with the same sort of thing. So 5 grams, not 0.5, and a temperature of 90. All right. And then it would say, don't click on that when everything is set next. And now you'll see this is now highlighted. So I can now play with the calorimeter. And for the next step, it says set the mass to water for 100. So we're just going to be dealing with water for all of these. And a mass of 100, it automatically sets the temperature. This does use the specific heat of 4.184, right? I ask you some questions, blah, blah, and then to actually run it over here, all right, you gotta always have to click next. That's the thing that took me the hardest to figure out. You're gonna click both of these so you can see what's happening. And then when you hit start, it'll be like, oh, you throw some stuff in, it starts going. You can see the temperature changing here and it'll show you the temperature here. And it's also trying to show you what's actually happening like as the things are colliding or whatever. And when it stops, like everything stops and that's how you know you're done.
So we don't need the papers at all?
What?
We don't need our lab papers at all? Okay.
Yeah, so this, because it was going to be way too many pages to have you try and scan and send me. I was like, no, let me do this on a form. And it'll have you like put in the final temperature and do the stuff. It's going to ask you to repeat it a bunch, all this sort of stuff. But pretty much once you get used to playing around with these buttons, it's really self-explanatory. So the lab itself, that's kind of like what you're doing. The lab is designed to take about 80 minutes because that's what we were doing in class. So you just need to budget time for it. I do not care if you do this in groups. So if you guys have set up your own Zoom accounts at this point, like you can do it that way. You can FaceTime each other, do a Google Hangout and like get a group of people and basically like all click the same buttons because it will give you the same data. So that way you can support each other in doing the calculations. But I do need a form for every single person. So you could do the stuff together, but just like you all turn in your own lab sheets, I do need a Google form from everybody. This is not due until Monday because I expect it will take you a little bit more time to do this. It's due Monday before you go to bed because we don't have class. I'm not doing class for us on Mondays. So you don't have to worry about that at all. And that's pretty much it. So the remaining office hours this week, I've got open office hours for anybody in all of my classes from tonight, 4 to 5. And then I have another set of specific office hours for you guys from 1 to 2 tomorrow. So I would say if people have homework questions, pop in tonight because I want that homework before you go to bed. If you have lab questions, pop in tomorrow, or if you just have other questions, do that tomorrow. You do have your next Ed Puzzle video that's due. It's due Monday night, and it's on mass spectroscopy, which starts our next set of packets. So before Tuesday's class of next week, you need to get through that reading guide for 5.1. And if somebody forgot to bring home those new materials that I gave you, send me an email and I can send them to you again. But that 5.1 reading guide, I did embed a lot of bit.ly links to simulations and videos to help you digest that material. And I really do suggest you go through that stuff. Some of the first part of 5.1 might be review, some of it might be brand new. And my goal for Tuesday's class is to go up through page 267 in section 5.1. So if you don't have time to completely finish the reading guide, at least make sure you get up through that page 267, and that's literally it. So as a review, the last things for me: homework before you go to bed tonight, the ed puzzle, and the lab for Monday, and reading guide up through page 267 for Tuesday. And that's it. So if people have questions, they can hang out for a couple of minutes. Otherwise, class is officially over and you guys can leave.
Ms. Baskin, I already did my Google form. Is there a way to like redo anything? I don't think I got anything wrong, but like if I want to go back and fix something.
You can just enter in the form. If you've already submitted it, you can just submit it again. That's fine.
Okay.
It's time stamped, so I can see.
Okay.
Bye, Miss Baskin.
Bye.
Bye, everybody.
Bye. Miss Baskin.
Yes, Ashir.
So I'm gonna just clarify number 9 real quick because this was my most confusing.
Uh-huh.
So the first one, we're finding our Q.
Yes.
I found that answer. Okay, the second one. This is H of fusion.
Yes.
Which means it's the other problem, right? It's the other Q.
Uh-huh.
So it's the other Q. I'm gonna write that real quick. It's not a Q. Okay. Number 3, specific heat capacity. This is like the same thing as number 1. We're just finding the Q.
Yep, and you should get a big number there.
Because we have. Okay. Number 4. What's number 4 like?
It's an HVAP problem, so it is just like numbers 1 and 2.
Q equals
It's
MC
literally
flat.
just like number 1, right?
That's what I was thinking. I didn't want to say it wrong because I wanted to say it.
Yep.
And then the last one is the same thing.
Yep. Q equals MCAT. Yep.
Okay, so number 2 is the only one that was kind of different. And then we add those all together, and then that's our answer. And then we do the 6 things.
Yeah. So again, before you add them, just make sure you put them all into kilojoules because all of your answers from Q equals MCAT will all be in joules.
And okay.
So like number 1, you should have gotten like 1,660 or whatever kilojoules. I mean joules. Sorry, joules. But once you put that into kilojoules, it's only like 1.66.
1.66.
Yep.
Miss Baskin.
Yes, ma'am.
So H fusion, like H fusion, that would be where you're melting at, right?
Yes.
Okay.
Girl, you got a lot of boxes of Nikes back there.
I don't know why I just keep them.
All right. Anybody else?
I'm still a little bit confused about number 7 on the homework. Is it kind of like the thing we just did in 4.6? Like, I don't get how to do it.
So that's the one where you set the 2 equal to each other. So it's like the last problem we did last class. Let me see. It's like, what number was that? Yeah, it's like the problem on page 222, number 1.
And you said it as negative, right?
Yeah, you set what, and it doesn't matter which one you do, but one of them is positive and you set one of them as negative.
Okay.
Okay, that makes more sense.
Okay.
All
Yeah,
right.
and if you want to send me a picture to be like, did I set this up right? Like, that's easy for me to check.
All right, thank you, bye.
Yeah, bye. All right. Okay. All right, I'm gonna kick you guys out so that the recording can actually work. So